Hello, guys. I am Stan. I'm the CTO of Scale Labs.
And I'm Christine, Director of Solutions Engineering at Scale Labs, and we're here to talk to you about running smart contracts on Layer 2. But before beginning, we will first like to level set and talk about the problem, the solution, and how it actually works deploying to a level 2 solution like Scale. And then we'll get into the code. So Stan, can you help us understand the problem?
Yeah, so you all guys probably can program in Solidity, right? We all love Solidity. In fact, all of you are here probably because you know Solidity. You know Solidity, MetaMask, Remix, Truffle, all of this stuff is something that all of you like, right? Otherwise you wouldn't come for this hackathon. So we have this thing where like thousands of people around the world know Solidity, Truffle, anything, and they love Ethereum. But we don't see many dApps actually being commercialized. We don't see many success stories in dApps. So there is this disconnect where lots of people are doing lots of things. There are all of these hackathons and stuff, but very little things actually get to be commercialized, to get real success. And the question is why this happened. And the most important problem is scaling. And scaling itself has several, pieces. One of the pieces is transactions. Transaction cost is high on ETH. You pay like 10 cents or more per transaction, can go higher due to market conditions, and also storing things is expensive, right? If you want to store like 256 bytes, you pay at least 10 US cents. So both storage and transactions are expensive, and that actually creates lots of problems for dApp adoption.
Yeah. And if that isn't bad enough, the other problem that we see is speed. So it's crazy to think that today you have to wait 40 blocks or 10 minutes before you can verify a transaction is being finalized. And it doesn't matter if it's in transaction or storing data. So what are some of the solutions that we have today to tackle this problem?
Okay, there are actually several solutions, several obvious ones, right? The one which many people have been using, if you don't have enough computation on blockchain, you just do it on a centralized server, right? So many people in the past did this stuff. For instance, EtherDelta, right? Lots of things on EtherDelta happened on a centralized server. CryptoKitties, and all of other people. But the problem is if you actually outsource your computation to a centralized server, you essentially break the idea of blockchain, and also you break the security of blockchain. So this solution is the most obvious, but it's very insecure. Now, as far as storage is concerned, there's another solution. There are storage networks. One famous storage network is Filecoin, and several years from now, we'll probably see these storage networks. So if you want to store lots of stuff, you will be able to use things like Filecoin, but these things are not available now and coming maybe 2 or 3 years from now. Then obviously, a very obvious solution is just to wait for ETH 2.0. Everyone knows ETH 2.0 is great. It's going to provide lots of transactions, lots of speed. But again, having the current plans, you have to wait like several years before ETH 2.0 becomes reality. And finally, the solution that we're working at scale is a sidechain. So it's something which is called layer 2 because it's a separate network. And it's a separate blockchain which is securely connected to the mainnet and is still decentralized. So it's still executed by independent people and has all of the advantages of a real blockchain.
So then how does this actually work? How would we actually use a layer 2 solution?
So first of all, let's define what a sidechain is. A sidechain is a fully decentralized blockchain. So in a very similar way to a real blockchain, to a layer 1 mainnet, a sidechain is executed by nodes, by independent people. So these people form a sidechain. As a dApp developer, you get your own sidechain on the network, so you don't have to share it with anyone. If you have a sidechain, all of the resources of this sidechain belong to you. So you get free and inexpensive transactions and fast transactions. And ultimately, the sidechain is securely connected to the mainnet. So essentially, you have two components. You have the mainnet, and you have the sidechain, and your application is deployed both to the mainnet and to the sidechain.
Cool. All right, Stan, can you explain more about what's going on here?
Okay, so a little bit later, Christian is going to show a demo, but really, the most important thing to know is that you all guys know Web3.js, right? Web3.js is a library that all of you, I hope, use to connect to the blockchain, right? In our case, since we have the sidechain and the mainnet, there are two versions, two clones of Web3.js that you run in your browser. So instead of running one instance of Web3.js, you run two instances. One points to the mainnet, and one points to the sidechain. And then most of your application is deployed to the sidechain. For instance, if you have a game, all of your game dynamics, all of the moves, all of this stuff is getting deployed to the sidechain, where things are free, almost free and fast and cheap. And then pretty much the only thing that you have to keep on the mainnet is where you accept money, where you accept ERC20 tokens. So we have a special contract which is called a deposit box. So if you want to accept an ERC20 token, this token is frozen in this deposit box contract, and the same amount of clones is created on the side chain. So the entire thing about transferring money from the mainnet to the side chain and back is becoming the process of this clone creation, where you froze money on the mainnet, you create clones on the side chain. You operate those clones, the clones are fast and easy and speedy, and then at some point, if you want to exit, you actually destroy clones on the side chain, and the corresponding amount of tokens is unfrozen on the mainnet. The connection between the side chain and the mainnet is secured using a cryptographic technique which is called BLS signatures or threshold signatures. We're using, some other projects are using it, Dfinity uses it. So threshold signatures or BLS signatures is very neat mathematical object which allows you to secure interaction between two blockchains. And finally, what's also really great is that all of this interaction between mainnet and side chains is made fully automatic. So we provide this machinery to you, and if you want to transfer money from the side chain to the mainnet and back, you don't have to know about all of the technological details. It's very easy. The money is simply is frozen on the mainnet, created on the side chain, and back.
All right, thanks, Dan. So now let's look at the code to see exactly how you would make something like this happen. Before getting into the code, though, let's first take a look at the dApp. And bear with me just a moment. OK, so this dApp is currently connected to Rinkeby. Right now, it's running two smart contracts, one for authentication and one for rock, paper, scissors, which is a game that we'll all play together later. But to show you just what the speed looks like, let's go ahead and sign up. And this is something that you're probably familiar with. MetaMask will open. It will connect to the blockchain, and then you will actually see the transaction come back. But one of the things that you'll notice is that it does happen really, really slow. So we won't wait for this. Instead, let's transition to the code so we can see what changes would look like for deploying to a layer 2 solution. So I have my dApp here. All of my smart contracts are already built. And I've already gone through the process that you would typically expect. I have my local Ganache solution here. I have Rinkeby that I've already deployed to as well. So what does it take to deploy to scale or a layer 2 solution? Well, it's really quite simple. I'm going to go ahead and cheat a little bit and copy this Rinkeby network module. Let's give it a proper name. And let's also go ahead and cheat a little bit, copy this Ganache one. Give that a name. And now what we'll have to do is connect it to an IP or end port that connects to your own S-chain that you'll create or will create for you. So in this case, I'm going to go to our dApp UI and pull that up. One of the things we're also building on our side is Adapt UI to easily understand how to create and manage your S-chains. So I'm going to switch this over to our private network so I can see and get that S-chain. Now, once this loads, what you'll have access to is your S-chains and all the RPC ports. Looks like. All right. So it looks like we're having some internet issues, but no worries. We'll switch to our own private one in just a second here. Bear with me just a moment, guys. All right. So let's refresh and try that again. Okay. Internet issues resolved. We now have our S-chains. Crisis averted. So if I click on the Scale Workshop here, the RPC endpoints will appear. And what I'll be able to do is simply copy that into my Truffle.js script. So I'm going to go ahead and copy this first one here and paste it here. Now, it really is that simple. If you're wondering what some of these other things that we're using Monomic because you have to sign the transactions, even if you're doing something as simple as deploying contracts. If you're not familiar with getting that, how you get that is you go to MetaMask, and you're able to retrieve that from your settings here. So just go to Settings, scroll down to Reveal Your C words, and that's where you'll be able to get your Monomic. Okay, so now that we have all the pieces together, let's go ahead and give this a try and actually run this, deploying my smart contracts to Scale. So I'm going to use Truffle again, Truffle deploy. We're going to reset because I've deployed this once before. I'm going to use a network for Scale. And let's go ahead and just compile them all again anyway. All right. Bear with me just a moment. Now, the typical process you'll see is going to compile all the smart contracts and then go through the typical deployment. Again, this is something that you're already familiar with. This has been done before with your local and Rinkeby testnet. But doing it with Scale was a very similar process. Once that's all deployed and done, we can then go back and actually test our dApp to see if it's working. So let's give it a few more moments here. But while it's doing that, I'm going to go ahead and set up my MetaMask to also connect to my Scale chain. So that same IP address and port, I'm going to go ahead and paste that in here for connecting. Go ahead and reset just in case there's any nonce issues going on. All right. And let's come back here to my demo application. And let's go through that again. So if I sign up, same process we're used to, MetaMask. One of the things you'll notice is the transaction comes back extremely fast. There's no waiting. There's no waiting 60 seconds, 40 blocks, 10 minutes. And we're able to proceed to our game and play. So who wants to play with me? Love it. Okay, so what should we select? Paper? Okay, paper it is. So we're going to go ahead and play this game. Again, it's a smart contract that we deployed to Scale. And similarly, what you'll see is in real time, we're able to process that transaction. So by using a layer 2 solution, you're able to speed up your smart contracts. Whether it's computational or you're dealing with transferring money, you're able to handle them both within our platform. Now, because it was a tie, we'll play again. Anyone else? Rock? Okay. So just to see it one more time because it was too fast, let's go ahead and come here and confirm these transactions. Oh, looks like we didn't win that one either. But to wrap it up, one of the things we want to make you aware of is that we do have a couple of bounties out. One for the Rocky Scaler. So if you decide to hack with us here at this hackathon, our #1 bounty, you'll receive $2,000 for creating a creative app that actually needs scalability. In addition to that, we also had 3 runner-ups. each for 1K each, and those are also the same qualifications: creativity over I guess having it finalized. But we really want to see exactly how you are actually going to use a layer 2 solution to speed up your smart contracts. So now we can open it up to Q&A. But before that, the last note here is that if you do want your own S-chain to run with, please join our Discord channel, and we'll make sure to distribute that to you. So any questions? All right. Sounds great.